as Christmas approaches, it's time to crack out lights like this common candle arch. Very popular effect. Looks nice in windows. You turn it on and it gives that bright sort of rack of candles type effect. But did you know that you can get LED lamps online? But did you also know you can't just take out a lamp and stick one of these in because it could have adverse effects? Let me explain why. I'll bring in my notepad here. Well, I'll bring in the listing first. This is just one of generic listings. The keywords are E10, LED, replacement, candle, fairy lights, lamp, and the key bit here seems to be 10 volt to 55 volts. And they sell them in packs of 10 to 50 pieces. And I noticed in the picture these ones, they're different from the ones I got. The ones I've got have diffused warm white LEDs in them. The ones they're showing have this sort of concave lens effect that's commonly used to get a sharp point of light. But here is why you can't just stick. Oh, I'm going to have to tame this down, aren't I? That is quite ferocious. This is why you can't just stick a replacement, an LED lamp in along the tungsten ones. So if you have, in our case, we've got 240 volts, and you have the lamps are effectively a series of resistors. That was a very badly drawn resistor. And I'm going to draw all 7 of them. It's pointless, but I'm going to draw them anyway. It will get the message across. So there's 240 volts, live, neutral, and the voltage across these is divided because all these lamps have the exact same resistance, just like fairy lights. And if I take one of them out, and I'll take one of them out right now, you'll see that when I unscrew this one, they all go out together. So it is just one in series with all the others. And if we do the maths, we can see that 240 volt supply divided by the 7 lamps is giving approximately 34 volts. That's about 34 volts across each lamp. However, occasionally you'll look at one of these displays in someone's window and one of the lamps will either be very dim or it'll be very bright. And the reason for that is that if they put in a different lamp, one that's rated for, say, 10 lamp set or one that's rated for 5 lamp set, if the voltage isn't matched, and I think these ones were specified as being, hold on, it's written on the bottom of the unit, 7 times 3 watt, 34 volt, 230 to 240 volt. If you stick in the wrong lamp, then you effectively put in a rogue value of resistor. And if you put in a higher value of resistor, the voltage across that one lamp could end up, say, 50 volts. And the voltage across the other lamps would drop to a different voltage. And you've probably done this with the old-fashioned screw-in Christmas lights that are in series. If you got the wrong lamp, it would either be very dim or be very bright. So here's the problem when you switch to LEDs. Although these are supposedly rated for use in this candelabra, if I stick one of these in right now, and I'm going to do it, I reckon it will suffer damage. It might not suffer damage, but I would expect it not to be too happy, and the other lamps to... Oh, they're actually lighting quite brightly. That's quite impressive, but I would say this lamp is most likely very stressed right now. I think I might just leave that for a while and see what happens. I'll be back in a moment. Okay, it's had a decent length of runtime. I have to say, I'm a bit disappointed. I was hoping it was going to go nuclear there. I was hoping it was going to fry the LED quickly because technically speaking, it's going to get a lot more. Oh, it's quite hot actually. It's technically getting a lot more. Oh, that is quite hot. I wonder if there's extra circuitry in there or if it's just a simple capacitive dropper. But the gist is that if you are changing to LED lamps, the current flowing through this whole circuit is typically going to be about 80 milliamps. I can check that right now. Let's bring in the flickery happy and let's plug these fairy lights into the hoppy. We'll let the hoppy boot up and we'll smack that in, and it's showing the current flowing through the string as about 90 milliamps. That's actually higher than it would be with the original tungsten lamp. So that's 93 milliamps. If I put in the original tungsten lamp, the current, it's about the same. It's about 89 milliamps. It's just gone up a little bit. That's interesting to note. Power dissipation, it says, is approximately 22 watts. Okay, let's put the LED lamp back in. I want to grill this thing. I'm not sure if it's designed to tolerate this progressive change them one at a time. But the current flowing is about 94 milliamps. Normally, if I change these all to LEDs, the current would actually only be about 10 milliamps. So it makes me wonder, is all that current going through the LED in this? I'm not sure. Interesting stuff, but the current has gone up. The power dissipation has gone up a little bit, so it's putting a little bit of stress on these other lamps. Let's change out completely then. Let's change them all for the LED. So I'll just turn the power off while I do this. I shall take the tungsten lamps out. When you do mix lamps in a string of lights, if the lamp you replace, if it runs dimmer, then it actually means that the other lamps are most likely running a little bit brighter and a bit higher dissipation, and they won't last as long. If it runs brighter, then that lamp is the one that will fail first. So let's put these in. Oh, that's it. That's tungsten again. Oops. Let's shove this one in here. I'm going to put a little blue dot on this one just to remind me it's the one that I've grilled. And I shall pop these in, and when I stick the last one in, I'll turn the switch on. All these should light, and we'll check the power dissipation again. This is something that happened in the fairground industries, because in the fairground, on fairground rides, the lamps, certainly in Europe, are usually about 60 volts. So that's them all lit. Is it my imagination, or is that one just a bit dimmer? Oh, listen, can you hear it buzzing? That's annoying. Right, hold on, let's turn this off. Is this one notably dimmer? It is. It looks like it's been damaged by being run at too high a current. Oh, that is really annoying. You can hear them. It's making the wood vibrate. That must be I wonder if that's the piezoelectric effect of the capacitors inside the droppers. The power has dropped from about 20-ish watts. It's dropped to about 1.2 watts, and the current is actually about 16 milliamps. I'm going to try swapping that one and see if it's something has happened to this. Are they all just buzzing anyway? Yeah, they're all just buzzing anyway. Rightio. I shall put the grilled one. In fact, you know what? Let's just open the grilled one. That's the best bet. Now, what I was saying about the fairground industry, quite often the cabochon lamps, the little crystal lamps, are... I can't believe how loud this is. That's annoying. Quite often they use 60-volt lamps, and there's a couple of reasons for that. The lower voltage across the lamp holder, in this case it's only going to be about 34 volts, but the lower voltage across the lamp holder results in the fairground lamps in less risk of arcing over inside, and it means that if a lamp fails, because the small lamps like these are very prone to sort of catastrophic failure if they're directly across the mains. If they fail, they often go short circuit because they create a little sort of plasma arc inside that shorts them out. And that can damage the controllers. So by having 4 in series, it reduces the risk of that. It also means the lower voltage across the lamp holder means there's less risk of that arcing. And also the lower voltage lamps are much more robust, so they tend to use these sort of, not these, it's a similar looking lamp, but they tend to use little 60-volt lamps for that reason, and 4 in series. You'll often see that 4 go out at once. When you replace them with LED ones, you have to make sure that if you're doing it with the power on, as often gets done in the fairground industry, because that way you can actually see which lamps are needing changed. When you take one of the old tungsten lamps out, the other 3 will go out in series with it. And you then have to make sure you take all those ones out before you put the LED one in, because if you just put the LED one in straight in, there's a very good chance it's going to kill the LED lamp, because being in series with the much lower resistance of the tungsten lamps, the LED lamps is going to see a bit of overcurrent. Right, tell you what, let's see if I can open this now. I want to see what's inside this, and then we can analyse the circuitry, which is almost certainly going to be capacitive dropper based. Right, this is glass. So I'm going to be a bit careful here. I'm going to get a bit of foam or something. There's a bit of foam. Doesn't mean that the glass isn't going to break right through the foam. I'm going to try and take this off here. Is this glued on? Is it an open-ended lamp? I think this may respond to heat. I shall give it a wee heat and we'll see if it makes any difference. Although, if it's held together, as these often are, by lamp cement, because it's made in the same sort of factories as make the traditional glass lamps, then it may not come apart easily. Let's just get that foam out of the way now and heat this up and just see if it actually works. It might not work, but there's no harm in trying. What I'm expecting here is a little circuit board with a rectifier and a capacitor and maybe a resistor. There's no smoothing. I could see it flickering like hell. So I reckon that it'll probably just be a capacitor, rectifier, and the LED, and maybe a resistor for inrush limiting. This isn't coming off easily. That means that to avoid broken glass and sore fingers, I'm just going to pause momentarily. Well, that took a lot longer than expected. It also involved lots of broken glass, but that's good because I was surprised at the amount of glass. I thought that these lamps were basically just going to have a little rim of glass that went into the top of this base and then glued in, but the construction is really, really interesting. It looks like the factory has used the same glass moulding and the same base as the ordinary tungsten lamp. And if you look at it, you can see, let's zoom down this just a little tad, just so you can actually see this. But you can see it's got this little stem that goes into the base, and it really does, it goes in quite far. So that will help make sure it can be glued in tightly. It will also help align it. But it also means that whereas with the tungsten ones, they probably have the little disc of glass with the wires going up the middle to the filament, and they'd butt weld it, so to speak, at the base. So you just had the two wires coming out the bottom. Because of the way they've made it, they've effectively used a little circuit board that is designed with the LED to fit up the inside of that, and then there's a little silicon sleeve around the circuit board, and when you press it into that, it can then hold itself tightly in position. And because it's holding itself tightly in position, that means that all they need to do is then fold up one wire, tuck it over the top like they would with the ordinary lamp, one wire through the base for the solder point end, and then the whole lot can be glued in. And the glue actually penetrated up quite far inside. It was quite hard to get it out and get it off. The circuitry is odd as well. Something really skewed me. I was thinking it was going to be something terribly sophisticated, because the fact that when I put that lamp in the other, in the sort of candelabra, the candle arch, I was surprised at how much current it passed. Well, the reason for that was because the little tiny capacitor inside had immediately died. It had gone short circuit inside, and I can show you the circuitry and then I'll show you the schematic. So here's a little capacitor, and it is just capacitive dropper. There's quite a high value of resistor. It's a 5615610 560 ohm resistor. And then the bridge rectifier is actually composed of two of these A7 dual diode packages. I would guess that maybe they used those just because it was a cheap way of getting a bridge rectifier that fitted in such a tiny area, because there really is very little room. You do get microscopic bridge rectifiers, but this would give very good spacing, because effectively one leg of the AC side is connected to the middle pin, which gives good separation between the output. And then in this case, they've just got the two of them together and they're just paralleled up. So the positive goes to the positive side and the negative goes to this negative side. In this case, this would be the positive and this would be the negative, which means I've drawn this schematic very slightly wrong, but it doesn't really matter. It gets over what happens anyway. If you look at the schematic itself, and I won't bother teeing that down. It's quite bright, but it's fine. If we tame it down, we see the capacitor has an unusually high value. That threw me initially. I didn't think it was such a high value. I ended up taking one out that was good, desoldering it and then measuring it. It came out around about 5 microfarad. That might mean it's a 4.7 microfarad with tolerance. So we get the 10 to 55 volts come in, we get the 5 microfarad, we've got the bridge rectifier based on the two A7s, which are rated for 100 volts, and then on the output we've got that 560 ohm resistor and an LED, and it is just a single chip LED, warm white. If you consider there's 7 of these lamps in series, then that, putting capacitor in series reduces the value. So 7 5 microfarad in series comes to about 715 nanofarads. That brings it down to a more realistic value for a lamp like this. But then we also have this resistor here, which you've got 7 in series, that multiplies the value of the resistor, and it comes to about 4,9 thousand ohms, 3.9 thousand ohms. And then you've got the voltage drop across the LEDs, which 7 LEDs, 3 volts each, it will just be around about 20 volts-ish. And when I put that lamp in, and I was saying, watch this, it will be damaged, the damage wasn't visible. Did you notice earlier on in the video, I was quite surprised I put that in. Everything seemed to be working as normal. All the other lamps lit at full brightness. In reality, the LED was passing about 88 milliamps. This resistor was passing about 88 milliamps, and that means it was dropping about 49 volts, and it was dissipating about 4.3 watts. That's why the base was getting quite hot. And I was actually wondering, is this something that's actually designed to go in to replace one of these lamps and somehow miraculously adjusts? And the answer is no, it had just blown up. Internally, silently, it had just died with a little squeak inside. And that basically bridged out all the current in the circuit was flowing through, in that case, without limiting, it was flowing through this 5 or 60 ohm resistor on that LED, which is why, of course, it was heating up. And the LED suffered a bit. It was a bit dimmer at the end as a result. And that's more or less it. So the most interesting about this is that they have, well, there's no smoothing. You may have noticed the flicker as well. That's simply because there's just no room. The circuit board in here is absolutely minute. The images I showed you there, they didn't have the usual cropping down, simply because I found it hard enough to even get close enough to actually get a decent in-focus picture in this. And, you know, if I'd blown it up any bigger, it would have just looked fuzzy. But it gets the message across. That's the rectifier from the 2A7s, the diode, and the capacitor and resistor. But the most interesting is the construction, how they have just repurposed all the existing components in the factory. So it's not just a plastic globe, it is glass, and it's got the same stem, it's the same machines will assemble it together. All they've done is retrofit it with this tiny little sleeved circuit board and LED that just replaces the filament assembly and just glues in instead of being melted in like the original factory equipment would have. And that just has the LED set at roughly the right height for the filament. It's very clever. It's very neat. But as I say, if you're going to change to LED, and the buzzing, I would guess it probably was that little capacitor was making the buzzing noise. It's hard to think of anything else that would. They do occasionally vibrate, and they make a sort of audible note like a piezoelectric crystal. Strange, but keep in mind we did have, they're not very big, but we did have 7 of them all running in the sync. But it's clever. It's neat. It's very neat. But keep in mind that if you are changing to LED, you have to take all the tungsten lamps out first and then put all the LED ones in before powering it up again. But interesting, well worth taking apart, as these things usually are.